Hello, everyone. Welcome to the Casual Causal Talk, episode 7. Today, we have a very special guest, Dr. Salil Pachare. He's an econometrician, a Ph.D. from the Yale University, and an interesting person who has transitioned from quant finance to e-commerce. We will talk about a lot of things about causality and how he has applied causal methods to quant finance and e-commerce. Salil, welcome to the show. How are you doing today?
I'm well, Venkat, and it's a great pleasure to be here on the podcast to discuss causality in a casual way with you today.
Yeah, welcome once again. Salil, you have specialized in economics/econometrics. What drove you to pick this specialization? Was causality always your interest?
That's a nice question, and thanks for asking. I think like my interest in economics stems way back, and it actually goes way back, I would say several decades to my high school days, where it was one of the subjects I took in my final 2 years of high school, and I really enjoyed it because it gave me the opportunity to sort of apply theory and sort of concepts that you learn. So very simple things like supply, demand, and so on and so forth, and see how you can actually apply that to the real world. I think my interest in, let's say, causality and so on, I wouldn't say it was always of interest, but it's funny when I think about this question because back also in high school, I took a course in something related to philosophy, which is called theory of knowledge, and topics of causality actually came up there. So trying to understand things like the scientific method and things like, okay, what is actually meant by causality? So, philosophers like David Hume say maybe causality, it's probably part of some sort of psychological habit that we have as humans, right? We only observe, let's say, series of events, but maybe it's just a psychological thing that we have that we say, okay, there is a cause to it all, right? And, you can think about these things philosophically, and that's, one interest that I have to think about this more in sort of the broader scope of things. But if we talk about causality in terms of statistics and so on, yeah, I think that would have happened probably in my undergrad days wherein I took a microeconometrics class, and one of the canonical questions that they ask is like, what is the impact of education on wages, right? And this is a classic, let's say, regression model, which is, the gateway into trying to understand a lot of things about causality. So things like omitted variable bias, instrumental variables, reverse causation, and all these sort of things. So I think that's where it happened back in my undergrad days.
Mm-hmm. Very interesting. What is causality according to you? Can you explain it in 3 levels of difficulty? I have taken this format from the Wired, where they have 5 levels,
Yeah.
but just to cut it short, we have just 3 levels. The 3 levels
Yeah.
are grandma. Of course, we are assuming that the grandma is not an econometrician.
Yeah.
Then there's the college fresher, and the third is the causal expert. So how would you go about describing what is causality to all these 3 people?
Yeah, that's okay. So let's say to your grandma, I'm just trying to think. I think an example here would be something like to your grandma, okay, let's say she's a gardener, and she waters her plants. She waters her plants, she watches them grow. So
Mhm,
maybe watering causes the plants to grow,
mhm,
right? Simple. So let's say to a college freshman, I'm thinking maybe at this level you could dive in and delve into differences between uh, things which are correlationally related and causation. And this canonical example that we all give is, ice cream sales and things like shark attacks, right? That they might go up at the same time, but I wouldn't necessarily say, eating more ice cream causes more shark attacks, right? They might be sort of related to this third variable, such as like weather. Like when it's nice and hot outside, people eat more ice cream. And when the weather's nice outside, people tend to swim outside and more likely to swim in the ocean and get eaten by a shark, right? So I would, delve into this and talk about correlation versus causation. The third one about explaining causality to a causal expert, right? I mean, I think this is where you can formalize this in a little bit more detail from the freshman, right? That you have some sort of intervention or treatment. And I look at, let's say, the outcome of this treatment. I look at this outcome of this treatment, right? But I think one of the fundamental issues about causal inference is this fundamental problem of causal inference that, you know, as an individual, if I receive a treatment or an intervention, I don't see what would have happened in the absence of that treatment, right? And that's the thing. You only see one or the other, right? And this is the fundamental issue of causal inference with the counterfactual. It's unobservable, right? And I think this is key in sort of formalizing this unobservable logic, right? And how do we deal with it? You know, we can go from one extreme of, you know, you can very well, if you have a population of individuals who receive a treatment, you can figure out some sort of average treatment effect through some sort of randomization, through a randomized controlled trial or an A/B test, as e-commerce people like to put it. But if randomization and so on and so forth might not be possible because of, let's say, ethical concerns or so on and so forth, you have to resort to, let's say, things like causal inference or quasi-experimental methods, right? We're going to talk a little bit more about those later, but that's how I would talk about causality to an expert.
I think that was very well explained. Thanks for that, Salil. My next question is centering around pedagogy. I mean, if you notice, you know, a lot of these causal experts come from predominantly the two streams. You know, either it is biostatistics / clinical trials, or it is from the, you know, econometrics or, you know, economic side. Do you feel there is some kind of an overlap in pedagogy between these two streams? Do they study the same topics? Yeah, you can explain. Yeah.
Yeah, I think I think that there definitely is overlap, right? So if we talk about what the overlap is in terms of causality, I think things like understanding outcomes, understanding the idea of counterfactuals, identifying models, and even I would say, let's say, measuring and understanding uncertainties through things like confidence intervals, t-tests, formulating hypotheses, right? So I think there's a lot of overlap there. I think where some of the differences lie is a lot of, like, say, economics and causal inference applications in economics are dealing with, let's say, observational data. And we deal with a lot of trying to identify causality under a lot more weaker assumptions. Right? So, you know, we have observational data and we have to sort of infer causality through maybe things like natural experiments. So something happened and one group just randomly got, you know, assigned a treatment because of this natural experiment, and so on. So we can't really run A/B tests or randomized control trials, which I think, from what I understand, is a lot of the case with biostatistics and clinical trials, right? You can do a lot more randomization and so on and so forth. So I think that's probably the key difference.
So would it be right to say that the nature of data and the objective, you know, makes, you know, econometricians choose a certain set of tools versus, let's say, you know, biostatisticians, given their objectives and data, they resort to, let's say, RCTs?
Yeah, I think, you know, you can resort to RCTs because, you know, maybe how the field has developed, right? You can run medical trials. You can get some population who and then randomize some sort of treatment to one and not the other and measure effects, right? I think with economics, right, there are potentially maybe ethical concerns with why you can't run an A/B test, right? You know, we'll talk about this a little bit later, right? Like, you know, a lot of the work I've done has been trying to look at the impact of regulation, right? So a regulation has been rolled out, right? But you can't randomize the regulation necessarily to one group of people and not the other, right? Because that could be construed as, you know, you're favoriting some people in society more than others.
Yeah.
So I think because the nature of the discipline means that we have to use different tools.
Mhm. Interesting. You worked in quantitative finance in your early part of your career.
Yeah,
That's very interesting. Tell us about your initial career journey there, and
yeah.
did you get to apply any causal methods?
Yeah, I did. So post PhD, my first job was actually in an economic consulting firm. It's called Cornerstone Research, and what I did there was we worked with legal clients in trying and to work on trying to quantify, let's say, economic harm, right? So let's say you have some sort of class action lawsuit wherein the investors of a company are let's say suing a company because they made some false disclosure, right? Maybe if we talk about medicine, right? Maybe it's a pharmaceutical company and they made some disclosure about, they have a new drug on the market and it has this really, it cures cancer, right? But when this information came to the market, it was then disputed and then the stock price dropped, right? And then now these shareholders are not happy, right? So the question we were asked is like, what is the harm? What is the damage done to these shareholders, right? And this is essentially a causal inference question, right? Because you have this observed outcome of this false disclosure. You want to know, okay, if this false disclosure hadn't happened, how would the stock price have trajectory? Sorry, what would the trajectory have been of that stock price? Right? And the difference between what actually happened and maybe that inferred counterfactual about the trajectory is the effect of the damages, right? So, I worked on these types of questions, and this is essentially causal inference, right? You want to figure out what happened, but you don't observe. So that was, I guess, my first, let's say, real world application of causal inference. And then I moved, I think, I moved then to the Securities and Exchange Commission, wherein this is a financial regulator in the US, and I was in their risk analysis and research, economic research team. And here it was pretty much it was pure, I would say, a lot of causal inference. We wanted to figure out what is the impact of various regulations, right? I can give you an example. So there was a regulation rolled out in the US about how firms should disclose some key financial information. And this key financial information is called short interest. We don't have to get into what it's about, but firms had to announce this number to the market. And this announcement happened on a very sort of on a very periodic basis. It used to happen once a month. Generally 3 business days after the mid-month or something like this. There was a rule. Now, this was increased to twice a month, right? So they would announce at mid-month and at the end of the month. And you wanted to figure out, okay, what is the impact of this extra disclosure, right? So this is a very nice causal question, right? Because you can use differences in differences, right? You can look at what happens before and what happens after this disclosure. But what I used is not just a difference in difference approach, but figuring out, okay, what is the placebo effect, right? So in the pre-period, you're only announcing this thing once a month on this specific day. Had you have announced it at the end of the month in the pre-period, you can figure out, okay, what is the difference between the actual and this placebo in the pre-period, the two actuals in the post, and take the difference in difference, and then you can actually figure out what is the causal impact of this regulation, right? So I used a bunch of different techniques. This is an example. It's like different diff and trying to figure out what is meant by a placebo, which is essentially estimating a counterfactual. I've used stuff like discontinuity design, instrumental variables, and so on. But that's
Pretty
what I've
interesting
done.
work.
Yeah.
I mean, just a improvised tangential question. I'm not a quantitative finance expert, but I mean, talking about, let's say, insider trading, do you think that insider trading is much akin to, let's say, the endogeneity problem, which we have in causality? does it cause endogeneity, basically?
It's a really good question and a really tough one. I think, right. I mean, I think the thing about insider trading, right, is the hard thing about insider trading is that you don't actually fully see it, right? Like you don't know what's happening behind the scenes, like who's telling who what is
Mhm.
the information flow which, let's say, led to this outcome, right? You see, for example, I don't know, some financial market participant buying a bunch of shares after something happened, right? Like the question, I think the real hard thing to answer is, yeah, it might be insider trading, but on the other hand, some people might argue that, it's just a mispricing in the market, right? So I think the real hard thing about something like insider trading is that it's really, really hard uh, to 100% say that it is what it is, right? Because there's this essentially is emitted variable bias, and this lends itself to endogeneity, right? Like there is this effect which is really, really hard to actually measure.
Yeah, I mean, let's say there's a organization, and they have developed an algorithm. I know share market prices are more like a Brownian motion movement.
Yeah.
You cannot predict share market prices accurately, but just for hypothetical sake, let's assume that. And then there is this really high level C-level person who has some kind of an insider knowledge, right? And he tries to short the market a little bit. For others in his company, they think that the algorithm is working fine, but they don't know that this person has done something which has, kind of caused a hampering, so as to speak, in the causal mechanism.
Yeah.
And that was my question, like, do you think insider trading is somehow, some kind of an endogeneity creation? Uh, Again, it leads to omitted variable bias. Nobody has included the information that this particular person knows something about
Yeah.
the market, but it ought to be included.
Yeah. Like the question is like endogeneity in what respect?
Uh, Endogeneity in the sense that this particular information that should not have been had by the C-level person, but it
Yeah.
is made available to him. And in terms of, in the perspective of the model, right? The model just thinks that, okay, everything is fine, but actually it is not. We should have included one more variable in the model, which says that, hey, this C-level person, knows something and he has
Hmm.
tinkered with the model. That's what we
Yeah, I mean that's tough, right? I mean, I don't. Yeah, I think in this example, right, like you can't really. Yeah, I mean, you can only really observe this post, right? Like post after the fact that the C-level person had this information, therefore maybe we should include it into the model and so on and so forth, right? I mean, I think definitely it is some sort of endogeneity problem, but yeah, I
Yeah,
mean
I
we're getting
know.
quite technical now, and I mean, yeah, it's a tough one.
Yeah,
It's a really
I took you off into a different tangent, but it was just a very curious question. Given
yeah,
your
yeah,
excellent
yeah.
explanation, my mind went totally in
Yeah,
that
it's all
direction.
good, all good.
Yeah, yeah. Uh, yeah, moving on. I can also see from your profile that you have worked at U.S. Securities and Exchange Commission, and you have also mentioned that you use some quasi-causal methods to infer causal effects there. Can you explain more about this?
Yeah, so it's what I just talked about was about the impact of regulation. So, for
Mhm.
example, you announce this thing to the market, and you increase, let's say, the frequency of your announcements to the market. The question is like, what is the impact of that, right? So, if you do it twice a month versus once a month, you can measure some sort of diff. And if you had in the pre-period also measured this in the middle of the month, this is the difference between your actual and your placebo. You have your two actuals afterwards. You can use pretty much a different diff there, right? I've also done things like discontinuity design, right? So we can look at, okay, if there's a regulation which requires someone to I don't know, disclose things or take some sort of action based on some threshold, let's say 10%, right? You can look at, okay, what happens to people or positions which are either side of that threshold, like, I don't know, 9%, 9.9% to 10.1%, right? Because economically, they might be very similar, but one is subject to a regulation and the others aren't, right? So you can look at some sort of measure of actual, let's say, somewhat localized treatment effect based around that threshold. So stuff like this.
Very interesting. You mentioned DID, difference in differences, right?
Yeah.
Difference in differences requires, first of all, a control market and then the parallel trend assumption. How did you go about choosing, the control market in this specific case?
Well, the control here is, right, like if you look at a regulatory design, which looks at sort of increased frequencies of disclosure, right? So you have, let's say, a firm which looks, how should I say, which has to make an announcement once a month and then twice a month, right? So each firm is, let's say, doing this, right? It's announcing once a month and then twice a month, right? The difference is essentially looking at what happens what is the difference between in the pre-period, the difference between announcing and what would have happened if they hadn't announced, right?
Okay.
Yeah. And then the post period is looking at what happens, okay, when they make these announcements. So you've got essentially a post dummy, which is what happens afterwards, right? A treatment dummy is, okay, they have to make the announcement, right? And then you can interact those two to figure out, okay, what is the impact of the announcement in the pre-period relative to the post-period and this treated effect and this causal effect.
Okay. Perhaps I was thinking more in terms of, the marketing DID that we do where we have to choose. But I think in quantitative finance, this is the way it is.
Yeah. I mean, we'll touch upon this later in some of my work at Kaufland. But yeah, I think in marketing, it lends itself a little bit differently in the sort of the DID applications, right? Because you have some sort of, I don't know, geo, which is some sort of control group, or some sort of channel which is fixed and not affected by some campaign, and so on. I think in sort of finance, it's a little bit different.
Got it. Salil, I have been following you on LinkedIn for quite some time. Some of your comments are really insightful, especially on statistics. How important do you think, concepts like linear regression, p-values, confidence intervals, and, NHST are for causality?
Yeah, I mean, they are important, right? Like, I think, but I don't think it's like, how should I say? I think they're important, but I don't think it's that they are fully sufficient in understanding causality, right? And what do I mean by this? So I think what I mean by this is these sort of techniques, right? They are there to help you understand the model, right? Like, there to help you figure out, okay, this is how you identify the model. Okay, this is how you measure the effect. This is how you understand uncertainty, right? How you quantify uncertainty through some sort of confidence interval and through some sort of development of your null hypothesis. But I think where, causality, where a bit more depth is trying to understand what is sort of the mechanism driving this, right? And taking maybe a step back a little bit to figure out, okay, this is maybe your outcome you want to measure. This is your how would I say, your driver, or your intervention, so to speak. This might be the path, or this might be the way that the causality happens. but these variables or so on might also be affected. Like these might also have an effect, and so on and so forth. So I think, statistics is important, definitely, but causality is a little bit more than that, right? I think it's more trying to abstract a little bit more and trying to understand what is the mechanisms which are driving what you want.
Mm-hmm. Understood. Because as you know, with respect to quasi-causal methods, especially DID, we already touched upon it, quite a few times in this talk already. It involves a series of, a linear regression construction, right? So I think the importance of, linear regression is definitely there when we talk about quasi-causal methods. If one can, I think I created a meme saying that, hey, you know what, if you want to prove causality in linear regression, you'll have to build many more linear regressions to prove causality on it. So that was my, thought process in asking this question.
Yeah.
I think, yeah, I mean, of course, statistical concepts are really important, but when we touch upon causality, there are certain things that are way more important. Let's say, for example, counterfactual. How important do you think counterfactuals are in establishing causality?
Yeah, I mean, I think, right, I think, to be honest, I think counterfactuals are probably key and very important, right? Because I think without counterfactuals, right, you can't fully say that X causes Y, right? I think what you can only really say is X is related to Y, right? X is sort of correlationally related to Y, right?
Mm-hmm.
And so that's why I think the counterfactual is so important, right? Because otherwise, you're just saying two things are actually correlationally related, right? But on the other hand, right, with counterfactuals, as I said before, with the fundamental problem of causal inference, it's unobservable, right? So you've got two spectrums, right? You've got correlations, right? So without a counterfactual, you can only say correlationally related, but on the other hand, you don't observe the counterfactual. So the question is trying to, I would say, come to some sort of compromise or middle ground wherein you are at least trying to say what would have happened absent the treatment or intervention, and trying to do your best to, let's say, observe or estimate that. Mm-hmm. And I think this is where, and everyone says correlation is not causation, right? But I think that correlations are still very important, right?
I think so too. I think there was an excellent cartoon of XKCDs. Yeah. I think it said that in the footnote. You know what? Correlation is not causation, but correlation, kind of hints you that there's something out there which could be causal. It's a hint, basically.
Exactly. And I think, yeah, definitely, right. And I think like any sort of analysis which you look at, definitely you should be doing some sort of correlational analysis first and trying to at least understand what might be related, right? Because okay, we've talked about with this ice cream example in Sharkas, right? You could have some sort of correlation. It's not causation, but it at least gives you directionally, like where to maybe look at, what to potentially consider in your universe, or in your universe of, let's say, possibilities or outcomes that you should, or variables that maybe you should consider in a model, right? And I think that's where correlation is really, really important. And yeah.
Interesting. I mean, going on to your profile again, I can see that, you transitioned from, quantitative finance to e-commerce. Yeah. Very interesting transition. What prompted this particular transition?
Yeah, I mean, that was, I moved to Germany, and I was working still in finance for 3.5 years or so, in finance. And my role within finance had more transitioned. I was doing more in terms of I was leading a team, but I was getting more, not really doing day-to-day work, let's say analytical work. I was more transitioning in terms of client engagement management, stakeholder management, and so on and so forth. And I felt I was going, I wouldn't say out of my depth, but I would say a little bit in a direction that maybe at that point I didn't really want. So I thought, there were two ways. I could try to do more quant finance work, or at least try something new. And, I think, causal inference was having some sort of, I wouldn't say revival, but I think a lot of businesses were starting to ask causal questions, right? And I think if we wind the clock back, it goes back to the early 2010s when I think Amazon was really the big, let's say, driver in terms of doing causal inference work in the industry, I would say. They hired a bunch of economists and so on and so forth. And a lot of people jumped on this causal inference train, especially in e-commerce. And, with the likes of, I think Pachare, who was, I think, the chief economist at Amazon, who sadly passed away. And then you've got the likes of things like Susan Athey, who's a big advocate of causal inference methods in economics, and applying these to e-commerce. I think she does some work at Microsoft Research. I realized that there was a big opportunity for actually this type of work within the e-commerce industry. So given sort of familial constraints, I was looking in Germany. I think this opportunity at Kaufland e-commerce came up. And they were looking for some people in causal inference to answer a lot of questions that they had. So things on loyalty, marketing, and so on and so forth. So I thought, let's try this. And it's been now 2.5 years, and it's been great. It's very thought-provoking work, and I wouldn't say it's easy. It's really, really challenging. And I think we'll talk about this, but I think some of the applications of causal inference are in real life are actually so challenging that they don't lend themselves really to nice, easy methods, right? You have to, you might be doing some matching, but you have to consider all these issues because that's how the market works, which are not necessarily inherent if you just matched, so to speak, based on some data that you have, right? And I think that's the key. You have to look at what industry are you working in, idiosyncrasies about the actual company and the environment and how people select and so on and so forth. And I think that's the really interesting part for me, combining these two things.
Yeah, I mean, it's been my experience as well. Of course, there is academic purity of, all these theories, but when you apply it into the real business settings, you may have to, compromise a little bit on the purity, right? You may have to bend things a little bit. Otherwise, it never lends, allows you to apply any of these techniques to real world problems.
Yeah. And this is the thing, right? So I think one of the real challenging things, right, in e-commerce is, a lot of people out there have just maybe digressing a bit, have access to, GA4, so Google Analytics 4 data, right? So if you have a website, you can, with anonymized IDs and sessions, you can somewhat let's say, track user journeys, right? So what people click, what people view, how much time, scroll depth, all these very granular sort of things, right? But there are sort of selection issues with that data, right? So people have to accept cookies, right? So there's this cookie consent thing. So not observing, I don't know, let's say 30% or 40% of your traffic, that's gone, right? So, you're inferring stuff based on just a selected sample of data. The second thing is, okay, in e-commerce, we can track people coming to our website, right? But what happens, there could be a lot of bounced sessions. So people come to your website, but then they don't take further action. You don't know why, right? You don't know if it because they slept at their computer, they got distracted, they went and bought the thing on Amazon or something else. Like, the session ends, right? So you don't have that full journey, right?
Mhm.
And in economics, right, or in the academic setting, you have full data, right? You have a full data set. It's a clean data set, but that's not how the industry works, right? You're dealing with this incompleteness of information, and you don't know why, but you have to somehow tell your stakeholders, "Hey, I need to make. I want an informed answer about what is happening. Please give me that answer, but you have to make this in this incomplete information environment."
Yeah, that's very true. I mean, we always deal with incomplete data, in
Yeah.
real world settings, and in an academic setting, yeah, the data is very pristine and almost always, complete. That's a very
Yeah.
interesting point. Uh,
Yeah.
Salil, I can see from your profile that you've done really impressive work in the e-commerce domain. One particular line item that caught my attention was, quantified impact of vouchers using Bayesian structural time series methods, leading to an incremental GMV of
Yeah.
13.5 million pounds per year. Oh, sorry, I think it is euro. Yeah. So can you explain to our audience what is BSTS and what was this method? How did it, benefit the organization?
All right. So let me first take a step back and try to sort of frame the method in terms of the question that we wanted to ask, right?
Mhm.
Um, I work in an e-commerce marketplace, which means that we bring buyers and sellers together. So sellers are people who want to sell their products on our marketplace, and buyers who come and then make these purchases, right? Um, so as a seller, right, you need to think about pricing, right? What I should sort of price my product at. And there are different ways to think about pricing and to offer this, let's say, discounts to customers. And one way was through vouchers. So, a customer comes to your website, they see, oh, okay, this is the product, this is how much it costs, and there might be a button, which is like the voucher, which is okay. If you click that, you can redeem 10 euros off that product, right? So we wanted to see, okay, what is the sort of the impact if a seller decides to, let's say, price this discount with a voucher, right? So the issue was that, this was like a pilot project, which was rolled out to, let's say, some sellers. So some sellers sort of opted in. We wanted to see, okay, what is the impact of this, right? So the question is, oh, all right, okay, a seller has this voucher for this specific product. People, let's say, buy it. GMV goes up, orders go up, great. The question is, okay, what is the effect of the voucher? So what would have happened? What would have been the effect on GMV or number of orders absent this voucher, if this product had not had a voucher, right? So how do we think about counterfactuals? So we couldn't really, we couldn't run an A/B test. I don't want to go into the details, but we couldn't run an A/B test. So we had to use some sort of methods like this. So how would the product have performed absent the voucher, right? So this is where we thought about using this Bayesian, structured time series approach, right? Which is you are using Bayesian methods to sort of fit what happens to these products that get a voucher in this pre-period, so before they actually get treated and get the voucher, and trying to fit that as close as possible, and then predict, okay, you have this now fitted time series. These are the products which do not get a voucher, are not treated. You see what happens after the voucher comes into place. And you want to sort of measure sort of the impact, right? And what we did was we looked at, okay, here are products that get a voucher. we have a bunch of different recommenders. So similar product recommenders, for example. So we looked at those recommenders. We looked at similar products, which are in the same, let's say, category as the treated product for the voucher, which do not get a voucher, right? So they're not affected by the treatment, but they are sort of closely modeled to the treatment. And then we looked at traffic coming from different websites and so on and so forth to create this counterfactual time series and sort of measure the effect. I think one of the challenges here is that no one's going to tell you, is your model good? Like, how should I say? How good is your counterfactual?
Yeah.
You don't know, right?
Yeah.
But I think this is the key. Like, it's better to say this. It's better to have some benchmark than to not have anything at all. Right? Like not having anything at all. You see, okay, it goes up, GMV goes up. But maybe that's a seasonal effect, or maybe there was some other effect which was causing this to go up. Maybe there was different changes in traffic, right? Like at least you're doing some sort of rigor to get this estimate of a counterfactual. So that's sort of what I did there. I've also done stuff on matching, right? So this is a real tricky one, right?
Oh, you mean propensity score matching? Just to clarify for the audience.
Yeah.
Okay. Yeah. Okay.
Yeah. So
I was about to ask about the next, accomplishment that you have had. I think it is about the loyalty card, if I'm not wrong, which generated.
It's about a loyalty card program, right? So, Kaufland, we have physical stores, so it's big supermarkets. But we're also a marketplace online, right? And so it's called omni-channel. And right, so we wanted to figure out what is sort of the effect of having this K card, which is a loyalty card, right? On things like GMV, orders, and so on and so forth, right? There are different ways you can acquire this card. You can acquire it in a stationary store. You can acquire it if you just buy online, right? But we wanted to figure out, okay, what is the effect of it if you just get it online, right? So the matching happens in a very controlled and nuanced way, right? We want to figure out, okay, I match people who have a K card versus those that don't get a K card at all, but they have to register on the same day. The person who gets a K card doesn't get it before they register on the marketplace, so they don't get it from the stationary store. They get it within a specific time period, at least a specific time period after they register online, because you get some people who just sign up for everything, just to get a discount, right? So I had to include all these sort of constraints. And this is what I mean, that you have to take into account the business logic into your models. So this was all business logic. And then it was more the propensity score matching, like looking at observables like GMV or orders, similar products that they bought, and matching based off of those covariates. And then looking at the behavior in this pre-period and looking at it afterwards. So that's...
Did you also match them on other attributes? I mean, if you can divulge it, you can. What I'm trying to ask is, were there other characteristics that you were trying to match them on? For example, demographics, gender. Did those play a crucial role as well?
Yeah, I mean, they could. But I didn't, and I'll sort of tell you sort of why. Like, I think here is sort of a tricky thing, right? You can see matching is essentially done on observables, right? Any sort of matching methodology, propensity score, synthetic control, whatever, right? You're doing it based on observables. So you can throw in observables, right? But there will always be some sort of residual unobservable effect. Now, the other issue is, and this is what I'm really trying to grapple with, right? You can get very good matching, right? And estimate some let's say beta, how would I say, some incrementality, right? But what often happens is your stakeholders want to know, okay, what is the aggregate effect of this? Like, is this incrementality that you have done via this very nuanced matching between a control and a treatment group, is this generalizable to everyone who has a K card?
Mhm.
And this is and because at the end, stakeholders want to know, okay, what is the impact of K card? They don't necessarily want to know what is the impact of K card for people who did not get the K card before they signed up on the marketplace and got it after 30 days and had it matched to someone who got signed up on the marketplace the same day. They don't want that. They want a generalizable result. So the question is, how do you generalize your incremental beta to an entire population? And causal inference is not necessarily going to tell you that, right?
Mhm.
And that's the thing. You can have great matching, but maybe with that extra matching, you can't generalize your results.
Mhm.
And that's sort of the tension.
Yeah, yeah, great nuance there. What specific algorithm did you use for propensity score matching? There are popular ones like, logistic regression, KNN, even XGBoost is used. Did you use any one of those?
Yeah, so I use basically logistic regression, right? So
Mhm.
you're using logistic regression to actually get an estimate of the probability,
Mhm.
and then right, so to ensure that you're getting the closest match, you use the one with, let's say, yeah.
Understood. Yeah, the deciles. Yeah, it outputs probabilities, and you kind of group people
Yeah.
into deciles and pick them up. Yeah, understood. Sally, let's play a small game. This is a game that I play with everybody. It is called the
Okay.
Rate the Causal Assumptions game. Yeah, so
Uh,
let me share my screen, and I'll explain to you what the game is all about. Let me know if my screen is visible to you.
yeah. Yeah.
Yeah, so the game is called the reasonableness of assumptions in causal inference method. So I have listed out a group of causal methods out there, and you will have to tell me whether the assumptions are reasonable, unreasonable, or impossible, keeping into context either quantitative finance or your current field of e-commerce. So let's go first with DID's parallel trends assumption. Do you think is it reasonable, unreasonable, or impossible? I think we can go first with respect to quantitative finance, and then we will do with e-commerce. Yeah, please go ahead.
Yeah, I think that's a good one. Oh gosh. Quant finance, I would say somewhat, I would say between reasonable and unreasonable. But with e-commerce, what I'm finding is that it's, I would say, a little bit close between unreasonable and possible. I'm
Okay.
finding that's what I think it's really, really hard. There's a lot of noise,
Mhm.
especially in e-commerce data. There's just so many things to sort of consider that a perfect parallel trend.
Mhm.
And it also really depends on the unit that you're looking at, right? If you're looking at a specific item, like in our case, we have 40 million items which are offered. Getting
Mhm.
parallel trends, if you're looking at an item level, is really hard.
Mhm. Great. Yeah, I think let's move on to Sattva, that is the stable unit assumption.
Yeah.
Maybe, yeah, we can go ahead first with quantitative finance first. Yeah.
When I think about Sutva, I
Mhm.
think more in terms of, let's say, randomized trials, right? When you've got sort of no
Mhm.
interactions between treatment and control. Um, in finance, right? Like, as I said, like it's really hard. We don't really run A/B tests as such. So I think
Mhm.
this is more, I would say this question or this application more relevant to e-commerce.
Okay.
And in that regard, I would say, um, it depends. I don't know
Okay.
what it depends means, right? Um, if I think about a randomized A/B test with anonymized users,
Mhm.
so yeah, definitely reasonable. But if I think about okay, I'm treated, right? I have sort of some ID item, some sort of item which is treated. There might be spillovers, right? Because there might be this product might come switched on, or a similar product might come switched on, which is maybe in the control, but it's part of some sort of recommender and so on and so forth. So there might be some leakage between
Yep.
treatment and control. So I would say it depends.
Okay. May I put it under somewhere between reasonable and
Yeah,
unreasonable here? Yeah.
yeah.
Okay. Great. Next, we have the sharp cutoff rule in RED. Again, something that you have experience with regression discontinuity design. Uh, Maybe we can go first with quantitative finance if that's where you applied it.
Uh,
Yeah.
I think it's reasonable, right? I mean,
Okay.
if you've got a regulatory design which has a sharp cutoff of, let's say, 10%, something has to be
Mhm.
disclosed, definitely, it's reasonable. But I haven't done much with this, but there are always these fuzzy matching
Mhm.
RDDs, right? And that's probably the line which I start the question,
Mhm.
the usage of the technique.
Understood.
Yeah, so
Yeah.
yeah.
So no application with respect to e-commerce, as I take it, right? For sharp, for RDD.
Uh, have I used? No. It probably can be used. I mean, I haven't used
Mhm.
it as of late. Yeah.
Understood. No problem at all. Let's move on to synthetic control method, the synthetic twin assumption, somewhat similar to DID's parallel friends assumption. Have you used it?
I haven't used this too much. Um, yeah, I mean, I don't know. I wouldn't know where exactly where I
Okay.
would put it. But
Yeah, we will leave it here. No problem.
yeah, yeah, yeah.
What about propensity score matching, the perfect balancing assumption?
Hard. I find it hard, right? I mean, I think I would say at some point unreasonable, impossible. Um, right. I think, and as I said, like we talked about, like in e-commerce, it's just there's just so many unobservables, right?
Mhm.
You can try to match as much as you can, but yeah, there's going to be unobservables, and also the question is about using a perfect match. You got a causal effect. How do you infer that to your
Mhm.
broader population? That's a tricky one.
Understood. Yeah, but thanks for playing this game, Salil. This was really insightful. I think we can move on to the other questions.
Yeah.
Yeah, thanks for that. Yeah, so my next question is more philosophical. What are the limitations of scientific methods to understand causality? Do you think our current scientific methods are not to the level which they should be to address or answer causality questions?
Yeah, I mean, this is a really good question, and I think I've been thinking a lot about causality, and I think one of the issues that I'm finding with causal inference is that all these techniques which we have talked about, right? They're essentially you're using them to analyze, I would say, kind of localized effects, right? So things like a discontinuity design, right? You're looking at effects around the threshold, or even diff and diff. You're looking at a pre-post period, which might be, I don't know, 3, 6 months or whatever, right? You're looking at or things like a local average treatment effect, where you're looking at instrumental variables, you're looking at non 100% compliance and so on, right? So you look at these very localized effects, right? But
Mhm.
causality is much bigger than that in the grand scope of things. If we're looking at things which slowly influence behavior over time, um, I think scientific causal methods really can't explain that, right? And this is
Mhm.
where discussions with, I don't know, people who are like historians or anthropologists or sociologists, can be incredibly useful for us, right?
Mhm.
You know, it might not be as quantitatively rigorous, but I think it's nonetheless important to sort of understand like what's going on, or just maybe, yeah, to understand maybe the broader picture.
Mhm.
Yeah.
Yeah, that was a very insightful answer, Salil. Uh, Moving on to, programming languages, right? I mean, everybody has one programming language which is their favorite. When it comes to, causal methods, do you have any favorite programming language?
Yeah, I mean, so 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 I'm an old dinosaur, and I would say like in my PhD and early work in the industry, I used SAS a lot actually. Um, and I mean, I think there would be a lot of, if there were any biostatisticians listening to this podcast, they would be thrilled. But I think as I moved more towards, I think my last job in quant finance and now in e-commerce, it's pretty much all Python.
Understood.
Yeah.
I mean, I have talked to a lot of econometricians, and Stata seems to be, popular programming language as well for, causal methods. But interesting that, you have used SAS. I'm pretty sure, biostatisticians will be pleased about this. So my last question, Salil, is that, what would be your advice in terms of, resource suggestions, books, blogs, or
Yeah.
YouTube videos for anybody looking to get started with, causal inference?
Yeah. Okay. This is a really good question. And it really depends on what do you want, right? Like there are people who are, let's say, academics who are wanting to get more exposed to causal inference, or there are people who have maybe not much exposure and want to get interested in causal inference. uh let's look at the first one, like people who have no exposure and want to get interest, who are interested in causality. There's a really good video series on YouTube by a professor at Duke University called Matt Maston.
Mhm.
I'll share you the name
Sure.
and link afterwards. And he's got this bite-sized videos, like 5 minutes and so on, and talking about causality, giving examples. They're mainly economics examples, but they encourage you to sort of think in a very
Mhm.
causal way. And I think this is really key. It's targeted, I would say, at like late high school or early
Mhm.
undergrad level. So it's not mathematical as such. He does put numbers here and there, but I think the key about this video series, it just encourages you to think in this sort of way.
Mhm.
And I think that's really important.
Mhm.
In terms of, let's say, people who are, let's say, more academic inclined and so on and so forth, um, yeah, a bunch of resources, right? I mean, I think, if you want some textbook resources, I would say, this has probably been recommended several times, but mostly Harmless Econometrics uh, is a great book. And if you want something which has some sort of technical rigor, I would recommend, actually, it's a microeconometrics book by Cameron and Trivedi. Uh, it talks a lot about, let's say, these econometric methods, and it also includes, causal inference applications. So that, and then the last resource is, of course, to see how to use, to see, let's say, modern techniques, so to speak. I would say, yeah, definitely causal inference for the brave and true.
Mhm. Matthew Stack, right? Yeah.
Yeah, yeah.
Yeah. Yeah, those are some great suggestion. And I would also add, follow Salil Pachare on LinkedIn. You know, that will be an
Thank,
excellent ad to it as well.
thank
Yeah.
you. Well, yeah. I mean, I don't post too much own content. A lot of my stuff is, let's say, commenting on posts. But yeah, if people
Yeah,
are,
I think
please
it's
follow.
very high time that LinkedIn came out with a feature where we can, bookmark the comments, right? I mean, I find a lot of interesting comments which I want to bookmark, but I have to unfortunately bookmark the entire article, but I kind of lose track on, what did this article talk about? Why did I even save it? Then I recollect,
Yeah.
there was somebody who was very interesting and they commented something. The comment was more, insightful sometimes than the post, it happens. I saw that with Adrian. I don't know, you follow him on LinkedIn. I mean, his comments are always more insightful, than the main post. But yeah.
Exactly.
Yeah.
Exactly. I mean, a bit of a digression here, but I think a lot of, let's say, the LinkedIn stuff, I find it's like, I save, let's say, articles, but it's also hard to actually sort through them and try to extract or search and so on. But yeah.
Who knows? Maybe with the advent of all this LLMs, we might be able to query comments pretty faster in the future very soon. I don't know.
That would be great. That would be great.
Yeah. Those all are the topics that I had to cover today, Salil. Thanks so much for your time. It was a really great talking to you, and thanks for those insightful, answers.
Oh, you're welcome. It was great talking with you, Venkat. And I look forward to, let's say, maybe chatting with you again, or seeing you online.
Yeah, I mean, I'm definitely going to have you back again because I have so much to talk about quantitative finance. It's a hobby, as I said. I'm not an expert, but I read, and I want to talk to an expert, who knows a lot about it and clarify some of my doubts and questions.
Yeah, for sure.
Yeah.
That's a long time ago, but it'd be great to talk again.
Yeah, maybe we'll have another podcast where we just dedicate it for quantitative finance, and we'll talk about that at length.
Sounds good.
Yeah. Thanks, Salil. It was wonderful having you. Have a good day.
You too. Bye-bye.